Andrew, regarding your post about the cold start challenge, waiting for the physical car to hit the track creates blind spot. What you're seeing here is Project Apex, my solution to validate the active Aero physics now, using the simulator as the ground truth, focusing on the left side. I've built a high-frequency Python bridge that captures 60 Hz telemetry. Instead of dumping logs, I'm processing the physics logic locally and pipelining it directly into Splunk Enterprise via the HTTP event collector. It's modular. Today, the input is the sim. For actual development, we simply swap the ingester for the Atlas SDK. On the dashboard, car 1 is accelerated on the left. Watch the bottom graph. There. The system instantly flags a critical event. At 250 kilometers per hour, the vertical energy exceeded the 100 joule safety threshold. Notice the latency, it's sub-second. We didn't just log the error, we visualized the instability trend immediately. This allows race engineers to abort the run digitally before it causes damage to the physical floor. This is key for correlation. Project Apex validates the synthetic truth today so we can trust the physical truth in Spain next week. I'm ready to deploy this for the MCL 40 shakedown. Let's get to work.